logical equivalence, or you can also consider which is nothing but the same behavior in logic. So yes, welcome back. So see, if somebody says that what is the same behavior in logic, so one thing that you have to understand is basically the logical equivalence. So if somebody says that the same behavior, what is the meaning of that? That means when you will have expression A and expression B. Suppose if you're talking about expression A and expression B, so what it says that? It says that expression A and expression B both should have a same behavior. What is the meaning of that? The meaning is basically, we can say that when A will become a true, B should also be a true. When A will become a false, B should also be a false. So that is a very simple concept. That is the meaning of a same behavior. So as I told you, if any person will be saying that what is a logical equivalence, then you have to say that the logical equivalence are basically defining as what? The logical equivalence are basically defining as it should be having what? It should be having the same behavior, right? So same behavior means what? The same behavior, it means that when the expression A becomes true, B should also become a true. When the expression A will become a false, B should also become a false. So that's the meaning of what? That's the meaning of, we can say that, which is nothing but the same logical equivalence that you will be having. Okay, yes, good afternoon to all of you. My name is Satish Yadav. So today we'll go and we'll talk about, that is nothing but about logical equivalence. Okay, so let me tell you about myself. My name is Satish Yadav, and basically I have trained more than 1 lakh of students, and I'm having more than 8 years of experience. My areas of expertise are discrete maths, DBMS, and all these things. Okay, so let's go and let's talk about the other things. See, sometimes the students thinks that how to prepare for anything, or what is the analysis and what should be the strategy. The students have different types of the questions in their mind. So what are the things that the students can perform, or what are the things that students can think about it? So here the Gradeup is giving you all the plans that is very, very important with respect to in terms of a preparation. So suppose if anybody says that how to prepare for something, so what are the important things in terms of preparation? The concept, the practice, the quiz, and then test series. So the Gradeup is actually giving you all the plans that is required in order to clear the examination. So the first thing is, Gradeup is giving more than 600 hours of live classes, and then 5,000 of practice questions, and hundreds of mock tests he will be giving, and hundreds of chapter wise notes that he is providing. Okay, so these all are the things that is very important with respect to what? With respect to when you want to understand, or when you want to go and when you want to learn about more things into that. Anyhow, this is each and everything that Gradeup is providing, and if you want to take a subscription, or if you want to have any particular concepts, you can contact on this particular number, and that is nothing but 9650 and then 052904. So in this manner, actually you go and you try to contact on this number, and I'm sure our team will be assisting you in a best possible way. Okay, fine. So let's talk about the logical equivalence, and here these all are the the extra of subscriptions the Gradeup is providing. So you can use this code, which is nothing but mantra 45, so that it will be helpful to all of you. And here also you'll have a free internet with Gradeup. So this plan is also provided by the Gradeup. So Gradeup community is helping you, the student, in a best possible way, so that you can learn and you can enjoy, okay, at the same time, obviously. Okay, so here we'll talk about the, which is nothing but the first rule that we are having. And what is that? That is nothing but the identity laws. Okay, see, if I'm talking about the identity laws, see, as I told you, there are certain laws into that, and how we can go and how we can understand in any concept. As I told you, you should have a two expression. So suppose if I'm having expression A and expression B, so how we can understand the expression A and expression B are logically equivalent? What you will do, take this statement as a true and go and check whether the B is going to be true or not. If B is also true, sorry, and go and check that if you're taking this as false, then see that it is also coming as a false or not. When it will have a same behavior, when it will have a same behavior, then we can say that it will become what? It will become the laws, or we can say that it is logically equivalent to each other. Now here, this is the first thing that we have to understand. So I never suggest anyone to remember each and every formula. Always try to derive the formula. See, here they have told that P and true, here that is logically equivalent to P, and here you will be getting P or false, that is also logically equivalent to P. Now what you have to do, see what should be the values of P. Value can be true or a false. So the first case that you people can take is basically, you can take P as a true at case number 1 and you will take P as a false. Now what will happen, if you will be taking true, so if you will put P as a true and true which has already been given, so what should be your answer? Your answer is basically true. So you have taken a true and your answer you are getting as a true. So basically when you are putting P, you will be getting answer as a P. What will happen if I will take a false? So if you will take a false here and if you substitute, your answer you will be getting as what? False. So you are taking a P as a false and the answer you are getting is basically false. When you are taking P as a true, your answer you are getting as a true. So when you are taking true, you are getting true. When you are taking false, you are getting false. So that's how we can understand whatever the values we are taking with respect to P, we are getting as a P. So always remember this thing, and obviously it will be depends on that. As I told you, when you will be taking and true, so when you will see and true, then obviously it will be totally dependent on that. So case 1, when you will take true, you will get answer as a true. When you will take false, you will be getting answer as a false. So that's how you can understand when it is logical equivalence or not. Now let's talk about the second case. As I told you, never ever try to remember anything. You can derive. Initially, before examination, when you will try to derive like 1 or 2 times, then you will get a confidence, you can derive each and everything, okay? Or the other things which I called is basically, it's called as a God's rule. So into the logic and or, and into set theory, intersection, union, and with respect to what? With respect to Boolean algebra, these all are equivalent to each other. When I'll be talking about with respect to what? And or with respect to logic, so this is true is same as a universal set and that is same as a 1, and here not same, basically correspondence. So false, that is same as or correspondence to phi and it is correspondence to 0. So this, if you know the formulas of a mathematical logic, still you can solve set theory questions with the help of logical equivalence, still you can solve Boolean algebra. It has been seen many times that student tries to remember the Boolean algebra formulas and then they can easily solve the set theory concept also, and you can also solve logical equivalence problem. So all things are basically important, okay? So what is my point? Okay, sir, can you tell me these things with the help of a set theory? Yes. So here is set A and then intersection and then you will be getting a universal set. What should be your answer? Your answer is going to be A. So still if you want to go with the logic, no problem. Still if you want to go with the set theory, no problem. Or a Boolean algebra, you will always be getting your answer. So that's how you can understand. So the 3 things are at one point of time. In set theory also it has been seen many questions they are asking with respect to this type of formula. In a logic, yes, obviously every year they are asking, and Boolean algebra obviously on alternate years you will be having the question. So you don't need to mug up anything. Or here also if you cannot understand, what you will do, try to take the values. Same behavior means what? When the left side is true, the right side should also be true. When the left side is false, the right side should also be false. That is the meaning of a same behavior. Same behavior, that means true, true, false, false. That's a very basic concept. When you don't know anything, what you will do, take left side as a true, check what is the right side. True, that is the case number 1. Check the left side as a false, go and check the right side as a false or not. So that is also the same thing. So in this way we can understand. I hope it is clear to all of you, and it's a pretty simple. The first law, identity law, because you are getting the same identity here. If you are taking P, you are getting P. If you are taking P in the second one, you will be getting a P. Okay, so that's how we can understand with respect to the identities law. Let's move to the next one, and that is called as what? Which is nothing but domination law. So here you will be having, why it is called as a domination law? Because here the T is dominating, here the F is dominating, and it's a very pretty simple concept. So domination law, what you will see that you will be getting answer as a true. Whatever you will write, it does not matter. You will always be getting answer as a true, because the OR loves true. Always remember this statement, OR loves true. As soon as the OR will see the true, it does not matter what you are writing this expression here. You will also always be getting true. And then second one is basically and hates false. So whatever you will be writing here, it does not matter. As soon as the and will see the false, the whole statement will become a false. And many times the students think that, sir, it is just a simple propositional variable. It is necessary we have to take just a simple propositional variable? No, it's not necessary. You can take any expression. Suppose if you want to take A implies B or C, okay, and then x implies, or take 100 variables, it does not matter, or consider as a one box that consisting of hundreds of variables, or that consisting of 200s of variables. It does not matter actually. What matters is basically when the OR will see the true, that matters a lot. So OR will see the true, the whole statement will become a true. And here when the AND will see the false, then the whole statement will become a false. So that's how you can understand with respect to the domination law. So here you will be getting, which is nothing but the domination law. The domination laws, what it says that whenever you will be having this kind of situation, you will be getting a true. It does not matter what you will write here. So this box consisting of one variable, simple propositional variable, fine. If it is consisting of compound propositional variable, again fine. Hundreds of variables, 200s of variables, it does not matter. You will also be getting the answer as a true. Let me do a revision a little bit. Identity laws. So and true here, and true, this will become the identity laws, and or true, this will become your domination law. Remember that. And here or false, it will become the identity laws, and here you will be getting and false. You will be remembering that. So try to remember, and hates false and or loves true. So these two things will be given by the domination law. So when you will know that, you can easily come up with this answer. Such that obviously or loves true, so reverse of that this. And hates false, reverse of that. So this is basically what identity laws. This one is the identity, and that's a domination law. So two rules we have already seen, which is with respect to what? With respect to the logical equivalence. Let's move to the another one that is called as the idempotent laws, and it's a very simple one. So obviously everybody knows that what is P or P and P and P. So there is no need to explain these things. Is there anything that need to explain here? What will happen if it is not a simple propositional variable, but it will be a compound propositional variable? Suppose here you will have hundreds of variables into that, and then same hundreds of variables into that. For example, A implies B or C, and here also A implies B or C. So that is also same as A implies B or C. Actually, when you are solving a question and that consisting of a large amount of variables, okay, when the question consisting of large amount of when the question consisting of large amount of variables, then at that point of time it is very important to take care about this type of rules, which is very, very simple. Fine. So we'll go with the idempotent laws, and that's a very sweet and simple. Double negation, that also everybody knows that, negation of P, that will be getting as a P. Commutative laws. So let me tell you about commutatives. What is that? If you are writing something on the left side and some operator, and then you are writing something on the right side, okay, so that is the left side operator, and then right side, and if you will change right side and then operator and then left side, when these two things are same, then we can say that it is satisfying the commutative properties. Okay, so you can use any operator, you can use plus, you can use minus, multiplication. So obviously we are understanding the logic. When we are understanding the logic, then what we have to do? Obviously we have to use the logical operator. That can be AND or any connectives, AND or single implication, double implication, or anything. Okay, so as everybody knows that this expression is going to be a commutative. When the laws consisting of simple propositional variables, then what will happen? It's very easy to go and it's very easy to visualize. But what will happen when it will consisting of hundreds of variables? Always remember that. So when it consists of hundreds of variables, then it is not that easy to visualize. So always remember, a box consists of hundreds of variables, and then this is nothing but box 1, and this is nothing but box 2, and that is same as, which is nothing but here box 2, and then OR, and here you will be getting, which is nothing but box 1. Okay, so this box consisting of hundreds of variables, this box consisting of 50 variables, and this box consists of 50 variables, this box consisting of hundreds of variables. So if you will interchange, you will be getting the same length. That is nothing but commutative laws. Associative laws. Many times the student used to get confused. Good afternoon, Hiren. Thank you for joining. Many times the student used to gets confused between the associative laws and distributive law. The associative laws, when to use the associative laws and when to use the distributive law. So here right now we are having the associative laws. So let's talk about the associative laws. Associative says that your operators are same and it is hidden or it is separated by the brackets. Okay, that is nothing but the associative. As you can see that your operator will become a same, or and or here, and here you will get and. So when your operators are same, then we have to go and we have to use the associative laws. Okay, when your operators are different and you will get the 3 variables, then you can go and you can watch, that is nothing but distributive law, and here you will have a distributive law. This page is quite important because the distributive law everybody knows, or it's a human mentality. When someone gives you this side, left side, logical equivalence left side, such that P or Q and R, when someone gives you the left side, you will be getting, or you can easily draw the right side. But the main hurdle is when someone gives you right side, then you does not get the visualization coming from right side to left side. So that is very, very important. So what you can do is basically P or Q here, and here what you will be getting, that is nothing but P or R. Okay, so always remember how to go from right side to left side. So that's a very important thing. So for that, what you can do is basically you can take P or PR. Always try to go and try to look the common terms that you can have. Here common terms you will have is P or PR, and then take this P or outside, P or outside. Now what you will get? You will get Q and R. So why I am telling you this? Because the distributive laws, the students always finds out, see, it's easy, obviously everything is easy, but the main problem is the confusing part. So the question is tough. The question will be tough when it will be consisting of a distributive law. Tough in the sense you will not get a visualization how to proceed. Then when the question, if you are not getting anything, and if it is a, see, remember this statement in GATE examination also, when you are not getting anything and if it consisting of and or, then try to understand there has to be a distributive law that will be moving from right side to left side. Okay, sir, what is the right side? Right side is this, it is moving. That means the question will be consisting of some part of like this, and then it is moving to here. That is nothing but distributive law. So in this way you can understand what is the distributive laws and how it is moving from right side to left side. So which is quite important. So always remember. And one more thing, distributive law, when you have to apply the distributive law when, which is nothing but when your operators are different. What will happen when your operator will become a same? Once your operator will become same, then we have to use the associative law. As you can see that associative laws, here operators are same, distributive law, here the operators are different. So please always remember this statement. When your operators are different, then you have to use the distributive law. And one more thing, De Morgan's law. Again, De Morgan's law is also very important. So this is regarding two laws. Okay, this one is quite easy, so I will not be focusing on that, but I will be focusing on the absorption law. Absorption law is very, very important. So let's go and let's try to prove it, how we can have this absorption law. So let's take example. Suppose if I will be saying P or P and Q. So first of all, how to find out something is absorption law? What is outside is inside, and operators should be different. Whatever it has been given outside, it has to be inside also. For example, this is P outside and P has to be inside, and your operators are different. Always remember. So that is the main concept with respect to the absorption law. What is outside, it has to be inside. That means obviously bracket inside, and then your operator should be what? Your operator should be different. Okay, your operator should be different. So what is P outside? P is inside, and your operator should be different. Now let's take the cases. So how we can understand the absorption law? Let's take the cases. What will happen if we'll put P as a true? Now if we'll put P as a true here, so here true or and true, and see, it does not matter what you are writing as a Q, because as soon as you will, this true will see this or, and I always say is this, or loves true. Always remember that, or loves true. When the or will loves true, and hence you will get answer which is nothing but true. See, it does not matter what you are writing as a Q. Q, it does not matter over here. So whatever you will write Q, even if it will become a true, no problem, you will still get answer as a true. Even if the Q will become a false, it does not matter, still you will get answer as a true. So this is a case 1 when you are putting what? This is the case 1 when you are putting which is nothing but P equals to true. So you substituted P as a true, you're getting answer as a true. So that defines what? That means if you're putting P, you're getting answer as a P. What will happen if I will put P as a false? That is nothing but second case. Now here, let's try to substitute P false, or here you will be getting what? Here you will be getting false and this thing. Now let's see that what should be the answer. As we can see that when we are trying to substitute this one, so this is and will see this false. Now what will happen? The right side, it does not matter what you are writing over here, because as soon as the and will see the false, this whole block will become a false, and false are false, you will get answer that you will be getting is basically false. Hence we can say that whatever the values that I will be putting, so this is basically your what? This is basically your case number 2. Okay, so case number 2, P is basically false. When you will try to put P as a true, you will get answer as a true. When you will try to put P as a false, you will get answer as a false. So that's how you will be getting, which is nothing but absorption law. Absorption law you can also solve with the help of you can say that set theory concept, as I have already explained you. So here you will be getting A union and then A intersection, whatever you will write it, or let's consider B. Now A intersection B, you will get middle part, and A union you will get answer as a. And here if I'll write A intersection A union B, okay, still you will get answer as a. So you can also solve with the help of set theory concept, and no problem into that. Okay, no problem into that. Okay, fine. So what I was talking about, absorption law. See, absorption law would be very simple. How to locate or how to get the absorption law, that's very important. So to get the absorption law is basically what is outside should be inside and operator should be different. So here whatever is the outside is P, inside is also P, and operators are different. When your operators are different, we can say that it's basically the absorption law. So this is a concept regarding what? This is a concept regarding which is nothing but absorption law. Clear? Okay, fine. So again, one more point I want to add into the absorption law. Suppose what will happen if I will write something like that. A and B or C, let's consider this is outside and then there is a or, and let's take same thing inside. A and B or C, and then after that this is or, and here if I'll write, and then let's consider some another variable. Still what will be our answer? Your answer will be A implies B or C. Okay, so you'll get, see, I don't care whatever you are writing here. I don't care whatever you are writing. I told you already what is outside is inside and operator should be different. Whatever the outside is A implies B or C, inside is also A implies B or C, and see that, see this or here and see here, and operators are different. So when your operators are different and what is outside and is inside is basically what? Absorption laws. So in this way we can understand. Negation laws, there P is also present, negation of P is also present. Okay. Okay. Okay, fine. So actually here we'll go and we'll, yes, hello. Okay, fine. So okay, let's talk about this. That's nothing but negation laws. P or negation of a P, and then you will get answer as a true. P and negation of a P, that you will be getting what? That will be getting answer as a false. So in this way we can understand, which is nothing but the whole concepts that is related to this. Okay, so this is absorption and negation law. Now here the logical equivalence, and that is related to what? That is related to, which is nothing but single implication. So we just have to understand the first one. If we can understand the first one, we can understand the whole thing. Okay, so suppose how these things are equivalent. You can also understand these things are equivalent. You can understand from a 2 point of view. And what is that 2 point of view? First point is basically either you can draw the truth table. So truth table is the best way, but actually it will take a lot of time. In GATE examination you cannot go and you cannot substitute the values into the truth table, and that will take a lot of time. So that's my point, is basically I can explain you that thing with the help of some other example. It's in a normal way of saying that, how we say is normally we says that don't go, or if you will go late to the office, then boss may fire you. That is P implies Q. If you will go late to the office, then boss may fire you. Or other way of saying that, negation of P, don't go late to the office or boss may fire you. So basically they are logically equivalent. We can also relate with the normal life example. Or if you do not believe on me, what you will do, try to draw the truth table. You will get the same behavior, what I have already explained, right? So that's how you will be getting it. Anyhow, so P implies Q. Now this is a contrapositive, and these two things are very important. So those students, if a gate question consists of implication and you don't know how to proceed and how to solve that, then always remember, in my class I used to call this as the God's rule. Okay, so if I say that remember the God, then you have to remember this particular statement. P implies Q is basically same as negation of P or Q, and P implies Q is logically equivalent to negation of Q is implying negation of P. So that's basically the God's rule. Okay, I used to say that God's rule, so that if I'll say anyone to remember that, so the student can remember it. So P implies Q is negation of P or Q, P implies Q is negation of Q implies negation of P. That's a contrapositive. These two things are very important, and as I told you, if a gate question consists of implication, then try to use these two statements. One of the statements will help you in all the possible way. This is, I'm telling based on the experience. Here you will have a P or Q. So what will happen if you put one more negation here, it will become P or Q. That means negation will be here. So actually it is same as this. Okay, you don't have to do anything. Now here you will be getting P and Q. Now this you can solve. That means you will get negation. P implies negation of Q, negation of P or Q. And now if you take negation inside, you will be getting P and, see here negation is there, P and Q. Okay, so that's a De Morgan's law. You can use it. So again you will be getting this particular law. Okay, so actually you just have to go with the first or second. Everything is quite simple into this, no problem. Okay, now you can also solve. Again remember the God, what is that? Negation of P or Q. So take negation inside. Here you will be getting P and here you will be getting negation of Q. So that's how. So this, the main important one, the main important thing is what? Which is nothing but this rule. This rule is very impressive and very important in gate examination. Okay, this one is also important equally, but I always suggest that I will be saying that P implies Q is negation of P or Q. Okay, that's the concept of, which is nothing but about logical equivalence. And here also these four rules are also very important. So I'll give you a trick, but don't believe on trick. You can also solve. See, when the first one is same, your operators are same. But when a first one is different, your operators will change. Okay, so remember, I will solve one and then you will get the idea. So let's take the second one. Okay, so here you will be having P implies R and here you will be having Q implies R. Remember the God, negation of P or R, and here you will get and negation of Q or R. So as I told you, remember the distributive law that is moving from the right side to left side. So R or R, R or R, what you will do? Take this R or R outside, what you will get? Negation of Q and negation of a Q. Okay, so take negation outside, what you will get? Negation if you will take outside, you will get P or Q or R. So that is same as what? Remember the God, P implies Q is negation of P or Q. So you will be getting P or Q and that implies R. So your operators will change when the first one is the same. Okay, when the first one is the same, then the operator will not change. But when the first one is a different, your operators will change. You can also apply with this. So even you can go with the proof, no problem into that, and that's a very simple one. Okay, so that's how we can go with that. And double implication. So double implication, you can have your own rule into that. It's so simple actually. P implies Q, Q implies P. So here you will have n number of a formula into that. Okay. So this is the whole concepts regarding, which is nothing but logical equivalence. Okay, so that's it for the today, and thank you so much for joining me. So yes, these all are the faculties who are having the classes, and yes, from 22 April we are also having the Hindi courses launching, and these all are the schedules that you will be getting. And on a Gradeup app you can also come and you can join our free session. Okay. Yes, you can use it. Fine. So actually this is nothing but with respect to what? With respect to the whole thing. And these all are the faculties who are taking the classes free. So if you people wanna join, then you can join on you can say that on a Gradeup. So you just have to download the app and then you can follow our notifications and you can come and join. These all are our rankers, and yes, that's it for the today, and thank you. See you on another session. And here this is the contact number, the customer's contact number. So for more information, if you'll be calling on this, our team will assist you in a best possible way. Okay, 9650052904. Okay, that's it for the today, and thank you so much for joining. So see you on another session. Thank you.